Welcome to 2045 Chemistry, Production of H2 Gas. In this particular lab, we'll experiment with various ideal gas laws, the combined gas law, Dalton's law, in order to capture H2 gas in a chemical reaction, but then determine exactly how much hydrogen gas we have captured. We'll deal with water vapor pressure. We'll also calculate moles of hydrogen and grams of hydrogen gas. Begin with measuring a sample of magnesium. We wrap our magnesium in our copper wire, but with a small enough diameter that it'll still fit inside of our burette. We check just to make sure. We go ahead and add 10 milliliters of 6 molarity HCl to our burette, then we fill the rest with water. Next, we submerge our magnesium into our burette. Note that mostly at the top of this at this point is just water because our HCl is at the bottom and it is more dense than water. So we'll stick our cap on our stopper. Our stopper's got a hole in it so that we can have the gas formation and our solution will be pushed out so that we can measure our gas effectively. So we'll go ahead and invert it and we'll stick it into a water solution inside of our beaker. And as we invert it, you can actually see the hydrochloric acid moving towards the bottom here. Look closely, it is more dense than water, so you will see it begin to fall. And it will reach the bottom where our magnesium lies, and it will begin to react. And you'll start to see the evidence of a chemical reaction almost immediately. We'll continue to let the reaction take its course. Eventually we'll stop seeing bubbles, so we'll stop seeing evidence of a chemical reaction, and we will assume that it has completed. We'll be sure to tap on the burette to get any lingering bubbles off of the copper wire and off of the side of the glass as well. So we will have captured all of the hydrogen gas. So at this point, we need to record the volume of gas. But first, we need to make sure that the pressure on the inside and the outside is equal. So we take it over to a large cylinder. We'll line up the meniscus of the cylinder and our burette, and we will measure for the volume of gas with equal pressure to the outside and inside. You may have noticed at the beginning of this video there was a quick photo that showed the current temperature and current pressure of the room. That's also the current temperature of this water, which is important for gathering the vapor pressure of the water. Please note the units that was presented in, because you will need to convert that into applicable units. You'll notice that there was some dead space in our burette where there are no milliliter signs, and so we needed to record that bit of volume as well. So we filled it up with water, we emptied it into a measuring graduated cylinder, and we see right here that we have the volume for that dead space. So we have the volume of our H2 gas, but we also need to account for that dead space, so we're going to need to add this to it to get the total volume of gas. And then, as always, we're going to repeat the procedure a second time, just to make sure that our results aren't out of line and they are pretty accurate and reliable. So we'll repeat the procedures one more time and be able to record the data as you progress through this last segment here of the video. And as we wrap this up, just a gentle reminder of those initial temperatures and pressures of the room and of the water, and a slight hint on how to solve for the volume of hydrogen collected. Thanks for watching.